In this video, we're going to take a look at graphing radical functions using a table of values and also by using transformations. So to start, let's take a look at what a radical function is. So a radical function is a function that involves a radical. And a radical is that symbol that looks like this here. It has a variable inside the radicand, so I'll put an x inside. Okay. And it has the symbol which is called a radical symbol. The expression inside is called the radicand. And then sometimes we'll have a number here. If we don't have a number, remember it means square root. I'll put a little y here. And that y stands for the index of the radical. So the radical function will have a restricted domain if the index of the radical is an even number, because we know that we can't square root, for example, any number that's inside which is negative. So let's take a look at the domains of these three functions here. So in this first one here, we are taking the square root of an expression. So we know that when we take the square root, the expression inside, the x minus 3, has to be a positive value. So this has to be greater or equal to 0. So we can then solve for x and say that x is greater or equal to 3. Now in the second expression, it's the cube root. And for cube roots, for actually odd roots, it doesn't matter if it's positive or negative inside, because we can cube root a positive or negative number. So for example, I can cube root 8, but I can also cube root negative 8. But here I can square root 4, but I can't square root negative 4. There's no solution to this one. So this one, because it can be positive or negative, we say that x is all real numbers. Now the last one, it's a fourth root. So again, because it's even, I can only fourth root something where the inside is positive, so greater or equal to 0. So we solve for x, and we have x is greater or equal to negative 3 divided by 2. So now that we know how to look at the domain, let's use a table of values to graph. And it's convenient to first identify the domain and then choose values for x that make it easy to calculate the corresponding values of y. So we're going to find the domain and range for these graphs first, and then we're going to use a table of values to graph. So the first one here, I started with a basic one. And we know that we just have a variable x inside, so we know that the domain is x, and the domain has to be positive, so greater or equal to 0. And then our range, because there's nothing else added to it, we can just simply say that the range is also greater or equal to 0. So when we square root, the number will always be positive. Okay, so using my domain that x is greater or equal to 0, I'm going to start with 0. And then I want to be able to square root some nice numbers. So I'm going to choose 1, 4, and 9. So when I square root 0, I get 0, 1 is 1, square root of 4 is 2, and square root of 9 is 3. Okay, so from here, I'm going to draw my graph. And 0, 0, 1, 1, 4, 2, and 9, 3. So when we connect these 4 points, the graph does keep going off and to the right, but it will go off to the left. So make sure that you have a solid point here at 0, 0. Now in the second question, again, we know that we have to square root a positive number. So we can say that x plus 3 has to be greater or equal to 0. So my domain is x is greater or equal to negative 3. Now again, because the whole expression is inside the radical, when I square root it, as long as it's a positive number, I'm okay. So that means that y has to be greater or equal to 0. Now when I find my x values this time, I'm going to start at my domain. So it says that x has to be greater or equal to negative 3. So when I put in negative 3, I can see that I get 0. So the next number, I need to pick something that's bigger. And when I choose negative 2 plus 3, that will give me 1, and square root of 1 is 1. Now, if we go back to our basic function, we can see that we're adding 1 and then we're going to add 3, and then we're going to add 5 to get our consecutive x values where we can square root really nicely. So we can actually do that here too, as long as you always remember that these perfect squares, they have a difference of an odd number. So negative 3 to negative 2, I add 1 to get that. So if I add 3 to the next number, that way positive 1. And when I plug it in, I get 1 plus 3 was 4. And look, I can square root 4, so it is 2. Since I added 3, the next one's going to be plus 5, which is going to be 6. And then again, I plug it in. 6 plus 3 is 9. Square root of 9 is 3. So I can graph and get these nice integers by using this pattern of radicals or perfect squares that I already know. So plotting this, I get negative 3, 0, negative 2, 1, 1, and 2, and 6, and 3. So you get a graph that looks like this. Okay. Now the last one's a little bit different because notice that there's a number added on the outside, but the number added on the outside doesn't affect the domain because we know that x, because it's inside the radical, it has to be greater or equal to 0. Now knowing that this smallest value of x, or the root x, is 0, 0 plus 3 would give me the smallest y value. So 0 plus 3 is 3. So that means that the range has to be bigger or equal to 3. So let's pick my numbers. And again, I'm going to start with 0 because that's where my domain is. Plugging in 0. 0 plus 3 is 3. We're going to use this pattern of perfect squares. So we're going to add 1. So I get 1. And then square root of 1 is 1. Plus 3 is 4. And then I'm going to add 3. So then I'm going to take 4, and the square root of 4 is 2. 2 plus 3 is 5. And the last one, let's do one more. Let's now add 5. And when you add 5 to my x value, you get 9. You can square root 9, which is 3, and 3 plus 3 is 6. Okay, so let's graph these points here. And there are the graphs of radical function. Now the other method we can use is transformations. So let's take a look at how to use transformations. So we'll review the order that we need to work in first. So here is a radical function. I've added everything that I could think of, a, b, h, and k. Notice that the k is not inside the radical, and neither is the a. And we're going to compare it to y equals root x. So recall that the a, that's the number in the front, that will result in a vertical stretch of the graph of y equals f of x. Sorry, y equals root x by a factor of a. Absolute value. Now the reason I put absolute value is to consider the negative separately. So if a is negative, the graph of y equals root x will also reflect in the x-axis. Next we have b, and b is, notice it's inside the radical, it's beside our x, so that's going to be a horizontal stretch of the graph of y equals root x, and this time it's by a factor of 1 over b, again the absolute. Now remember that we're using absolute to make it easy, but if it were 0, then the graph of y equals root x is reflected in the y-axis. Okay, h is next. Notice the h is also inside the radical beside the x. So the h determines the horizontal translation. If the h is positive, the graph is going to be translated to the right. And if h is less than 0, the graph is going to be translated to the left. And lastly, we have k. K is outside. So notice the location of all of these numbers is not inside the radical. So k represents a vertical translation. And it's on the outside. And if k is greater than 0, the graph of y equals root x is translated up. And then when it's less than 0, the graph is going to be translated down. All right, so let's take a look at a couple examples. Now, when we do these examples, like before, we need to move all the numbers and the constants to the one side, away from the y. So when I take a look at this one here, I can see that it's nicer to rewrite this as negative root 2x and then minus 5. So the mapping notation, if my point was originally xy, I can now see that this is going to be x divided by 2, because the 2 is what makes it compress. And then my y value, we have the negative and the minus 5. So we have negative y minus 5. Okay, now remember what we're comparing is, we're not using square roots or anything because we're always comparing to the square root of x. So my basic function, if you recall, is y equals root x. Okay, so let me make a table of values. So this is my basic function that I have from before. And that's my original. So when I apply the mapping notation, plugging in these x values into the question, I get 0, half, 4 over 2, which is 2, and then 9 over 2, which is 4.5. Plugging my y values, 0, 1, 2, and 3, into the question, I get negative 5, negative 6, negative 7, and negative 8. So let's graph to see what this looks like. So I get 0 and negative 5, half and negative 6, 2, and 2, 4, 6, negative 7. And then my last one is 9 over 2, which is 4.5 over negative 8. Now make sure that you don't connect these points in a straight line because they're not straight. It's a little bit curved. And there you go. All right, let's take a look at one more. So here we can see that we have only the 2 that's affecting the y and the negative and the plus 3 that affects the x. So my mapping notation would be negative x and then take away 3 to move it left, and all my y values will be multiplied by 2. I'm going to use the same table that I had from before, this red one here. So I'm going to plug all these red numbers, the x values, into the first part. So I get negative 3, negative 4, negative 7, and negative 12. My y values, I'm going to plug in 0, 1, 2, and 3. So I get 0, 2, 4, and 6. And I can graph these values here. So negative 3, negative 4, and 2, 6, 7, 7, and 4. And I can't graph the negative 12 because it comes off a little bit. So I'll just graph those 3 numbers. Oh, and now we're going to connect my 3 points. Remember, it's always going to be like an arc like. Okay. Oh, and let's go back to do the domain and range. So once you have the picture, it's actually really easy to see that the domain is going to be greater or equal to 0 since it starts here. And the range, it also starts here and then it goes down. So my range is y less than or equal to negative 5. For the second graph, it starts here at negative 3, but notice that this time is pointing to the left. So the x values are less than or equal to negative 3. And my range, it starts at this point on the x-axis and goes up. So y is greater or equal to 0. Now, one thing we can do just to double check is that inside the radical, I have, this has to be positive. So I can say that negative x minus 3 has to be greater or equal to 0. Negative x has to be greater or equal to negative 3. And then divide by both sides by negative 1. So x is less than or equal to negative 3. Don't forget to flip the sign when you're dividing by or multiplying by a negative number.